Hi, Mr. X with glossary term matrix multiplication. When we multiply matrices, they have to be a certain order, not necessarily the same order or size. If they're square, that's fine. 3 by 3 times a 3 by 3 will give us a 3 by 3, no problem. But this is a 3 by 2. And this is a 3 by 2. We're not going to get a 3 by 2. No can do. Here's what we could do. We could, however, multiply this 3 by 2 by this 2 by 3 and get a 3 by 3. Whoa. Really? Yep. And it would go like this. We would usually write this with a subscript, C sub 1, 1. Here's how we would multiply these matrices. Because this is first row, first column, we take the first row times the first column. That's how we get C1, 1. In our sum matrix, this is first row, first column. First row, first column. So we take the first row times the first column. Sum of products. The A times the 2 plus the 4 times the 5. First row, second column, we take first row times second column. First row, third column, take the first row times the third column. To get these individual products, C21, just keep it straight with row and column. So we take the second row of the first matrix times the first column of the second matrix. Second row, first column. Second row, first column. Second row times first column means we get this. Second row times first column. C22 is second row times second column. You have to take these individual products and sum them. B times the 10, negative 7 times square root of 2. You do a dozen of these, you become an expert. So far, so good? You following this logic? Use the subscripts. Again, these are usually written with subscripts. And I'll go ahead and put them in here so you can see how I would answer this, so to speak. But it's really not that hard. As it turns out, the 3 by 2 times the 2 by 3 will give us a 3 by 3. And what has to happen is this number has to match this number for multiplication to be possible. If it does, then your resulting matrix will be these outside numbers. That's how we multiply matrices. These numbers must match, and then this will be the order of your resultant matrix, the one that results from multiplication. If you don't have the same number of columns in the first matrix as you have rows in the second matrix, then you cannot multiply matrices. That's how it works. All right, let's fill this in for you. We have multiplied a 3 by 2 times a 2 by 3 and gotten a 3 by 3. So understand that this 2x plus 5 radical 6 is a single element in our sum matrix. And how did we get to 2x plus 5 radical 6? Well, because in our resultant matrix, we're in third row, first column. We took the third row times the first column. That's what this is. Third row times first column. Third row times first column. Third row times first column. That's why this number has to match this number in order to do matrix multiplication. And that's why your resultant matrix are these outside numbers. I'm talking about the outside of this little diagram right here. So where did we get to 2x plus 5 radical 6? Well, we got it from this. And where do we get this? From taking the elements in the third row of the first matrix times the elements in the first column of the second matrix. Like I say, after you do a dozen of these, piece of cake. On the World Wide Web at MrXMath.com.